Okay. So hi guys, thank you for coming. My name is Mario Fusco. I'm from Italy, and I work on rules, the rule engine of JBoss. But today I'm here to speaking about something quite different, that is functional programming in general, but more specifically how we can do domain modeling with function. Okay. So first of all, let's clarify what is a functional program, or why what I mean when I say let's do functional programming. A functional program, of course, is something that is made of pure function, meaning that your code have no observable side effect, meaning that you are not allowed to do all of this stuff, okay? You cannot reassign a variable, you cannot modify a data structure in place, setting the field, throw an exception, this is important for me, printing to the console, or reading the user input, reading from, or writing a file, or drawing to the screen, okay? You cannot do all of this stuff. And this means that basically, if you really follow this list, it means that your program will not take any input and not produce any output. So the only visible side effect will be to warm up the CPU, and that's all, okay? But the reality is this, there are two subgroups of these things that you should avoid. The first group, you should really avoid to do that stuff, because it's not considered functional programming. In the second part, of course, you need to do the stuff, okay? You need, of course, to, again, read the user input or produce some output. But you can do this stuff at the extreme margin of your program, okay? Think to your program like an onion. The core of the onion is the pure functional thing, okay? So it's just made of pure function that doesn't have a side effect. And the external part of the program contains these side effects, okay? So this is the main idea. So functional programming is not a restriction of what you can do, on what you can achieve, but just a restriction on how you can reach that specific goal. And you add those restrictions because you can have some advantages that I will try to underline during this talk, okay? So the biggest difference, in my opinion, between object-oriented and functional programming is that they both try to they both try, of course, to reduce complexity, or it's a way of managing complexity, okay? And the complexity comes mainly from mutability. But they follow two different strategies. The object-oriented just encapsulates the mutability, while functional programming try to completely minimize or avoid it at all, okay? Why do we want immutable stuff? Because there are a few advantages. Immutable API are easier to use, are easier to design, are easier to implement. They reduce the possible interaction between the object of your domain, and even more important, they are inherently thread safe, okay? Because if your objects are immutable, you cannot have race condition, you cannot have multi-threading problem. So the point of this of my talk is showing with different example how you can move from object-oriented to functional design, okay? So I need to make a quick premise because when I did this talk in past or similar talk, the question was typically, do you really expect that we do this stuff in Java 8, okay, but in Java, that is a strong object-oriented language. It has a very strong object-oriented bias. And my answer is that, of course, I don't expect you program this way. I don't do it myself, okay? But the point is that till now, you have been exposed to the extreme right of the object orientation. And my purpose today, my goal today, is to show you the extreme black of functional programming. And the reality is that there are 50 shades of gray in the middle, okay? So your task is to know both the tool, know both the technique, and find the right shades of gray, the right combination, the right mix of object orientation and functional programming for the task at end, okay? Because the real big advantage in Java 8 in the introduction of lambdas is that you can mix both paradigms. Okay, so let me start with a very, very simple example, with a story that I want to tell in 2 different points of view. This is the object-oriented point of view. So the story is that we have a cat that catch a bird and eat it. Okay, that's all. So I'm modeling this story with my object that are, of course, the bird and the cat that has a mutable state. When you call capture, you assign the catch variable. And then when you call it, you set the catch variable back to null. And of course, at this point, the cat is full. Okay? So the way you play this story is creating this cat on this bird and call these 2 methods on the cat object. Okay? This is the object-oriented way of modeling this situation. Let's try to check the functional counterpart. Again, we have a bird, but this time I have 3 different types of cat. Okay? I have a plain cat, angry but without a prey, without a catch. I have a cat with a catch, okay? And I have a full cat. So when I call capture, I'm returned with a cat with a catch. And when I call it on the cat with a catch, and I call it only on this object, I'm returned with a full cat, okay? So let's review this story, okay? So the point of view of this story is a bit changed now. The story really is the combination of the 2 sub-story, okay? I do the capture, and then I do the eat. Okay? It's really 2 sub-story and the combination of them, okay? So what can we notice here? Of course, we can notice that now my objects are immutable. This is something very typical. In object-oriented programming, in object-oriented domain modeling, the accent is on nouns. Okay, the important part are the nouns. While on functional programming, of course, the emphasis is on function that are verbs. Okay. This is another quite typical thing of functional programming is that I try to use the type system in a more expressive way. Okay, as you can see, I have 3 different flavor of cat because I'm modeling part of the state of the cat using different classes. That's why. Okay, and The other really important thing is that you really don't need to test this stuff. I mean, it compiles and it works in this specific super simple case, of course. Okay? Why? Because you cannot call it on a cat that doesn't have a catch, for instance. Okay? You are guided to, you are obliged to follow the happy pet in this case. Okay? Okay. So again, I told you the center of your program becomes the verbs for what regards the domain modeling, becomes the function for what regards, of course, the programming. Okay, and what you will find doing this is that functions compose way better than objects. Okay. Objects are more similar to the tile of a puzzle. You have to put them only in a specific place to make them work together. Functions are more similar to Lego blocks because they are super small. They are super specialized in one single super small task. Okay, and then it's easier to reuse them and to combine them. I hope I will be able to show example that justify these claims in the next part of this talk. Okay, so let's give a more practical example. I have my API to buy something from a web store. So let's suppose this is the Amazon API to buy a list on item, and when I do this, I'm returning with a cart, and then I can use the cart to call the next method, and I'm returning with an order, and then I can use that order to call the next method. Okay, so if you design your API this way, you have again, you have a story made of sub-story. You have a fluent combination of this function that will drive you to the happy path. So let's suppose we want to implement the one-click buy feature of Amazon. Okay, what is that? It's just a combination of these three things. I do the buy, and then the buy will return the cart, so I can call order on it, and I will be returning with the order, and then I can call deliver on it. Okay, so it's the same thing as before. Now, just in a more practical point of view, I mean, I'm implementing my story that in this case is the one-click buy as the combination of three, as the composition of three sub-story. Okay. Another important thing of functional programming is that data and behaviors are the same thing. You can treat them in the same way. You can pass to a method. You can pass to a method both data and behaviors in the same way. And this is very common, even in past, even before introducing the lambda expression in Java 8. You did this with the anonymous inner class, okay? But this is a very typical example. This method is there in the collections class since Java 1.5, I think, or even before. So you pass to that method both the data, the list of items to be sorted, and how you want to sort them, how you want to compare two items of that list, okay? So, for instance, if my data are a list of persons, and I want to compare them by age, I will do this, okay? So what I'm doing here, I'm passing to that method a data and a behavior, exactly in the same way, okay? And if you think about it, this is the trick also that enabled the MapReduce, that makes the MapReduce efficient, okay? Because if what Google did when they invented the MapReduce algorithm, the idea is that, okay, I have two machines, and I have the computation on this machine, and I have the data on this machine, okay? I have the program on this machine, the computation that will work on the data, and the data here. But what's the problem? The problem is that my data are a few gigabytes or petabytes of data, while my function is 1 kilobyte, okay? So what should I move the data to the computation or the computation to the data? Of course, I want to move the computation because it's just 1 kilobyte. But why can I do this? Just because I can use data and computation, data and behavior exactly in the same way. They make no difference for me, okay? Otherwise, I will be obliged to move the data, okay? So what is this? This is an high order function, okay? Why? Because sort is it's a static method, meaning that is a function, is a method without a state, so it is a pure function. And why this is an higher order function? Because I'm passing a function to another function. That is the sort function, okay? That is the comparator on which I'm defining the sort, okay? So for some reason, I found that higher order functions are not so easy to understand idea for Java developers. And I don't understand why. I mean, I don't think it's rocket science. And actually, this book speaks about higher order function. But the problem is that they never call them higher order function, okay? But they are. Think about the command pattern. What the command is? You pass a command to an object. And what the command is? It's the command of doing something. It's another function, okay? It's the function that you have to execute to apply the command. The problem of the Gang of Four book is that it is totally biased on the object-oriented side. So there is no concept of function, no concept of verb, okay? Verb are second-class citizen. So when you have to use verb, you have to wrap it inside an object, you have to wrap it inside a known, and then you are allowed to do this. And this is what the command pattern is all about, okay? You cannot pass a function because it doesn't exist the concept of function, so you have to artificially wrap that function inside a command, then at that point it's an object, and at that point you can pass it to another object, but it's totally artificial. Let's do another example based on the Gang of Four pattern, on the strategy pattern in this case. So I want to define a converter that is, a simple, super simple object that allow me to convert between different unit of measure. So I have this abstract method that is convert, that to which I will pass a value, and I will be returned with the converted value. And then I have an abstract converter in which I'm implementing this convert method, and I'm just multiplying the value for a given conversion rate. And of course, when you have the actual implementation of the strategy, you will just have different value for this conversion rate. So in this way, you can define a miles to kilometer converter by passing the right conversion rate for doing this conversion, and ounce to gram converter for doing the same. Okay. So how do you use this stuff? Okay. I'm developing here a method that converts a list of value with a converter. Once again, this is a bit artificial. You see, the converter is just a function. It's just a conversion function, but I get to wrap it inside this converter object, okay? Because I don't have the notion of an higher-order function, so I have to artificially wrap the conversion function inside an object, okay? And okay, at this point, I can use these two different convert to convert a list of value, again, from miles to kilometer or whatever you want, okay? So let's see the functional counterpart. The functional counterpart is this. I have a converter that is a by function taking the conversion rate and the value to be converted, and with it will be return a value, okay? And I'm not extending the native by function of Java 8, but I'm writing my own by function that extends the native one. Why? Because the by function doesn't have these two methods. The method to carry the by function and transform it in a function of a single argument, okay? So what carry one in this case means? It means I have a b function of t and u to r, okay? And carry means I'm fixing the value of t, and then I'm returning with a function from u to r, okay? It's very simple, right? And the same thing is the other function, but with the second parameter. So why I'm useful this concept of carrying in my converter example? Because I have my converter that is a super general converter, and then I could do this, okay? I could convert 10 miles by passing the 10 miles and the conversion rate. But if I have to convert a number of different figures that are miles to be converted in kilometers, I don't want to pass the conversion rate every time, of course. So what I do, I use the carry, okay? I fix the value to the conversion rate, okay? And when I do this, I'm returning this converter that is a by function, is a function of two arguments, is transformed in a function of a single argument. Why? Because the other argument has been fixed to the conversion rate that I want to use. Okay? So what I'm saying is that I have this super general converter, and using the carry, I'm specializing it. Okay? I'm fixing the conversion rate to the value that in this case is the conversion rate from miles to kilometer. And then I have a specific converter for that conversion. And I can use it with the Stream API. Why I can use it this way? Because this is a function. Okay? I'm not creating this object wrapper, this object-oriented infrastructure that is not really useful. I have a function, and I can use this function directly in my Stream API. Okay? Let's see a similar but a bit more complex example, but I just wanted to show you how this is a better approach, because with function composition, this approach becomes more flexible. In some cases, in most of cases, doing a multiplication is enough to perform a conversion. When you have to convert from Celsius to Fahrenheit, this is not enough, as you know. You have to add a fixed value, 32. So what you do, you take the converter, you carry the conversion rate to 1.8 in this case, and then you apply another function that adds 32 to the result. And all this stuff, it is a function, okay? So you can happily ignore that this stuff is the composition of two functions. For your point of view, from the user point of view, this is just a function that takes a value and returns a result. And you don't have to know how we created this function, okay? you can use it as a black box. But you don't have to redefine it every time, because you are using these Lego blocks. You are using this super small function, and you are reusing them by composing them, by combining them. Okay? Same thing. Okay, I did the same trick as before. I needed this compose method that are present in the function class in Java 8, but not in the by function one. So I'm implementing this compose method by myself. Why I'm doing this? Because I want to do this opposite conversion now. I want to go from Fahrenheit to Celsius. So I have my converter, but this time I have to do something before. I have to subtract 32, okay? And then I compose, and then the same thing as before. At this point, I can ignore how the main function has been created as the composition of the two sub-functions. I can just use it, okay? Okay. Let's switch to a different example, okay? Feel free to ask questions, of course. Feel free to interrupt. I have a salary calculator, okay? I want to implement this salary calculator. So I have this calculate method that takes a basic salary, gross salary, and I'm return it with the net, okay? And the operation I have to do is that I may or may not add an allowance or bonus, pay taxes, or pay a surcharge, okay? And may or may not means that together with the basic salaries, I'm passing here are varargs of Boolean, an array of Booleans, okay? For brevity, I'm not doing any check on the length of this array. I'm assuming you are passing an array with 4 Booleans. And each Booleans here represent the fact that I should or shouldn't apply the corresponding tax or bonus, okay? So how I use this stuff in this way. And here the problem is clear. I have to remember the exact sequence. I have to remember that the first Boolean is the allowance, the second Boolean is the bonus, and so on, okay? And this is not a nice API, okay? So in object-oriented programming, what do I do to resolve this problem? I create a builder, right? So I'm creating a Fluent builder with a few methods. I will have a method with allowance that set the allowance flag to true. And in this case, I'm creating this in a Fluent way, so the method itself returns this, so I can call other methods on this builder. Of course, I need with bonus, with tax method, and so on, okay? And then the calculate method does exactly call the original method, but you don't have to remember the exact sequence of the Boolean flag. So how you use this stuff is that you have the salary calculator builder. You are applying the bonus, the tax, not the other two things. And then you can calculate the net salary in this way, okay? Okay, so this is the object-oriented way of solving this problem. Let's try to check how we can do the same, or if we can do better with functions. First of all, let's try to isolate the tax rule, the business rule, okay? My business rule in this case are these 4 functions, okay? That are pure function if you think about it. They just take a value and return a different value. That's all, okay? So I can isolate them in a utility class, a library class, okay? And at this point, I can do this. I have a list of functions, and I have width with a function, okay? I pass a function to this width method, So I add this function to the list, okay? So when I calculate the net salary, what I do? I transform this list of function into a stream of function, and then I do a reduce, okay? What the reduce does? The reduce start with a 0, and then combine two values in the stream with an operation, okay? So let's think about this. If I want to add, if I have a string of integer and I want to calculate the sum, how I do this with the reduce? I start with a 0, and then the composition is the plus, is a plus b, okay? If I want to multiply all of them, the 0 for the multiplication is the number 1, okay? And then in the combination, in the function that combines the two things, I will a times b, okay? And I'm doing exactly the same here, but with function. What's the 0 of function composition? It's the identity function, okay? It's the function that when you pass a to it, you are just returned with the same a, okay? And then what's the composition? The operation to compose the two function is the and then method, okay? So what I'm doing, I'm creating a new function that is just a composition of all the function in the list, and at this point, to the resulting function, I can call apply by passing the basic salary, okay? What's the advantage of this? Is that now I have only one single with method. I don't need a list of with method for each kind of taxes I could apply, okay? So I can say with salary bonus, because I'm using the method reference of Java 8, and with salary tax, okay? So you can read it. You have the same readability of the builder version, but you have just one single with method. And the other plus of this solution is that you have extensibility for free, meaning that if you have a new function to apply, a new tax that you didn't foresee when you implemented the model, a regional tax in this case, okay, you can just pass this new tax as a lambda, as a function, and you are done. I'm doing exactly the same thing here. I just wanted to fix something that was wrong under my point of view in the former version, meaning that the former version was mutable because I was appending function to that list of function. I don't want to do that. I have an immutable salary calculator here. So this salary calculator start with the identity function. And when I say with, I create a new salary calculator that as function as the combination of the current function and the one you passed in, okay? But this is does exactly the same thing, works exactly in the same way as the one you saw before. It's just immutable. Okay. As you saw, I had the need to create a few utility function, a few abstractions that are not provided out of the box in Java 8. That is a shame in my opinion. But there are a few libraries that does this for you, so you don't have to reinvent the wheel. I really suggest, if you want to try to do this stuff in Java 8, to use this library that is called JAVASLANG. It's developed by a German friend. It is very nice. It has a few useful things that you start missing in Java 8 when you try to do some real functional programming thing. So you have the tuple, you have immutable collections, okay? So what is an immutable collection? Is that a collection that you don't mutate in place the data structure when you call it. When you call, for instance, add to a list, you are not adding something to that specific list. You are creating a new list with the new item on it, okay, without touching the existing list. That's why they are called immutable collection. And then you have some other nice thing for doing a kind of pattern matching, provided the verbosity of Java syntax that, of course, is not ideal to do this stuff, but could be nice. Okay, let's see an example of this stuff at work, and let's have a coffee break. Okay. Okay, so I have my cafe class, and I want to buy a coffee. Okay, so I have my buy coffee method, and this method is passed with a credit card, and it returns. Then when you execute this method, the credit card is charged with the price of the coffee, and you are returned with your cup of coffee. Okay. And then, of course, you may want to implement a version that allows you to buy more than one coffee. Okay, you are in the bar with 3 friends, so you want to buy 4 coffee, and you don't want to call this method 4 times, but you want to pass 4 here. Okay, and this method, of course, internally reuses this method by calling it 4 times, okay, and returning it with your list or 4 coffee, okay. But what's wrong in this? First of all, okay, I have a side effect here, okay. Because why? Because I'm changing the state of an object that I'm passed in input. I shouldn't do that, and this is a problem. On my point of view, because what you do, for instance, to test this method, okay? You create a mock, and then you pass the mock to the method, and then after you have called the method, you assert something on the state of the mock, okay? So that's, I really don't like this way of testing stuff, okay? I really don't like mock and stub, and yeah, it's very bad design. In my opinion, if you find that you need to use mock to test your API, you have done something wrong in your API. What's the other problem? A very practical problem. Suppose that you are charged with a fee every time you use your credit card. To buy your 4 coffee, you are not using the credit card only once. You are calling charge 4 times. You will pay 4 times the fee of using the credit card. You don't want this, right? Okay, so let's try to fix all this problem. What's the problem here? The problem here is that this method is producing 2 results, okay? That is the one that you want, that is your coffee, and the side effect, your credit card is charged. And it's producing that second result as a side effect, okay? And it doesn't to be this way. The method produces 2 results, then you returns a tuple of 2 values. That's a simple solution. Okay, so what I'm doing here, I'm returning your coffee, and I'm returning a charge value that is modeling that the fact that your credit card has to be charged of the price of the coffee. But it's not charging it right now. It's just returning the charge object. Okay? So super simple. And let's try to implement again the method that allows you any number of coffees. In this case, what I do, by the way, here, this is not the Java 8 stream, it's the JAVASLANG stream. It's the stream provided, but the library I mentioned to you, but it's quite compatible with the Java 8 stream. So what I'm doing, I'm creating a stream by invoking once again this method n times, okay? Subsequence is the method that corresponds to the limit of the Java 8 stream, okay? So what is return? This returns a stream of a tuple of coffee and charge, okay? And I want the opposite. I want, instead of having a stream of tuple, I want a tuple of streams, okay? So this is why I do the unzip. This is what the unzip does, okay? And then at this point, how I can produce my result, I just transform this first stream in a Java list, and then I do a fold left on the, and then I have n charges here. I do a fold left, so I will combine the 4 charges in a single one, okay? So in this case, I'm returning as I wanted with a list of coffee with my 4 coffees, but 1 single charge, okay? That is what I wanted. And again, if I want to test this method, I don't have to pass some mock here and do fancy stuff, okay? I can pass an actually credit card because I'm not really charging it. I'm returning it with 2 values, and I can do assertion on this value when I test it, and I can do also assertion on the charge to check that I've been charged of the right value. Okay, I don't need to use any mock in this way. Okay, next thing. Another thing that is something it's bad it's somewhat bad in functional programming is using exception for error handling. Okay, I really don't like exception. I think they are just a glorified multi-level goto. What's the alternative? The alternative is that once again, use the returned value, okay? If a method invocation can fail, you don't model the failure with an exception. You model the failure with a returned value that clearly states that that computation may fail, okay? So you have quite a few options in this case that are, for instance, provided by that library, by JAVASLANG. You can use a try that wraps the value, but models. It's the same thing of the Java 8 optional, okay? With the optional, the value may or may not be there or could not be initialized, could be null. With the try, the value may or may not be there, and it couldn't be there because just the computation failed, okay? Or the second option is the either. That is exactly the same way as the try, but the only difference is that also the error is typed, okay? So you have a generic also for the type of the error. And the other alternative, the stronger alternative is using a validation, okay? What's a validation is? Same thing, but the other problem with the exception is that they doesn't compose, okay? So the first error you will get an exception and everything blows up. But maybe a computation may fail for a different reason, okay? So what you are modeling with the validation is that you are accumulating in this list all the things that went wrong while performing that computation, okay? So let's try to make one last example. Okay, as you see, I'm trying to use very common domain modeling that are more or less the domain that we use in our day-by-day life. Okay, I'm tired of reading articles or watching presentation that tells me how to do the Fibonacci series or to do a factorial with functional programming, because be serious, you really do a Fibonacci series in your day-by-day job? I don't think so, okay? But very likely you have to deal with a bank account, okay? So that's why I'm bringing these examples. Okay, so I have this bank account that is made by an owner and the number of the account, and I have the balance, okay? And I have two allowed operations that are credit, so I'm put some money on my account, or debit, I'm taking some money, okay? And of course, if you don't have enough money in your bank account, this object-oriented version will signal this problem by throwing an insufficient balance exception, okay? So the moral of this story is that when you give money to the bank, everything is always okay. When you try to take money, something may go wrong, okay? So what's the problem here? Okay, the first problem, you already noticed it, is that I have this mutable balance that I don't like. It's not really functional. But the other thing is that I'm signaling, I'm reporting the problem, the eventual problem, by throwing an exception, okay? So how I use this stuff? I have a list of accounts, and I wanted to take $100 from each of these accounts, okay? And I want to collect in this list all the creditors that couldn't pay me, okay? So I do a try catch in this for loop, and every time the debit method throws an exception, I collect the account inside this unpaid list, okay? What's the problem with this? One of the problems is that this is the old style Java version, okay? It's the external iteration version. But if I try to use the internal iteration, things are not really better, because lambda doesn't play well with checked exception. You have to put the try catch block inside the lambda exception, and you end up with an ugly syntax. And the other problem of this solution is that you are mutating an object that is outside the enclosing scope of the function, okay? But the main problem really is the ugly syntax here. Okay, so let's try to use a try to model the error in a different way. What I'm doing here, I'm using the try that, by the way, is a monad. And what this means that it's a monad, this means that it has this map and flat map method, okay? In general, the map method on a monad defines how you apply a function on the object wrapped by the monad, while the flat map defines how you compose to monad, how you compose to tries, okay? So let's see this at work. I have my try interface, and I have two implementation of this interface, that is the success and the failure, okay? So with the map method, when I want to transform, when I pass a function to the map method, I transform it from A to B, I just apply the function to the value, and I'm returning with the success of B, okay? With the flat map, I'm just passing, again, flat map, it's similar to map, but with the difference that you are composing to monad. So you are not passing with a function from A to B, you are passed with a function from A to the monad of B, to the trie of B in this case, okay? So the result is just the application of this function, okay? The failure. If you are failure, you are already failed. There is no way to recover this stuff, okay? So both the map and flat map just return the failure as it is. They cannot do much, okay? What I'm saying here is saying that the flat map is, again, the way how a success composed with another try that could be a success or a failure. So if I'm composing two success, I will be returned with a success. If I'm combining a success with a failure, I will be returned with a failure, okay? And of course, if you try to combine a failure with anything else, the result will be a failure anyway, okay? So that's the meaning of the flat map in this case. Okay, so let's try to re-implement that bank account getting rid of the exception. Okay, so what I'm saying here is that the only difference is here. Okay, the balance is no longer mutable. I'm creating a new balance every time, but the important part is here because I'm no longer throwing an exception, but I'm signaling that this method could fail by returning a try. Okay, so what I do, how I do the task that I did before with that ugly try catch in this way. I create a stream. A stream of the account that I want to charge, and then I map this, and I'm returned with a tuple containing the original account and the result of this debit operation. Okay, and then I filter all the operation that returned a failure here. I take the account and I collect them into a list. That's all. Okay, and I could write this stuff actually in a shorter way by concatenating the debit and the is failure invocation in a single invocation. I believe that it is true that this stuff is more compact, is shorter, but I believe this one is more. I don't know, for some reason I like it more because it is more readable in my opinion. It shows really the steps that are going on, but both are acceptable. Okay, so let's do a further step. Okay, I really want to work with pure function. Okay, so as I did before with the salary calculator example, I'm moving all this function in static method that are pure function in this way. I don't have an state anymore, okay? So I can open an account with an initial balance, and I'm returned with a try account because this could fail. The credit cannot fail, as you remember, while the debit may fail. Okay, it's exactly the same thing. The only difference is that I don't have an account. I'm not calling this method on an account object. I'm passing the account object every time. Okay, I'm creating one here, and I'm passing the account object to the credit and to the debit method instead of calling them on the account instance. That's all. Okay, but in this way, everything is stateless. They are really pure functions. Okay, so how I use this stuff? I open my account, okay, and then I want to perform a few operations on this account. So I do a credit and I do 2 times, and then I do a debit, okay? While I'm using map or flat map here, I'm using map because, of course, this is a function from A to B. It's a function from an account to another account. And I have to use flat map here because here the function is a function from A to a monad of B. It's a function from an account to a try account. So I need to use map for the credit and flat map for the debit. But the compiler, once again, sorry, guides you through the happy path. It doesn't compile if you did this wrong, okay? So this is the way to use my functional bank account that is made of pure function now, okay? But there is a problem, I think. You are used to use dependency injection, right? For instance, you want to inject a connection to the bank, a bank connection into your account to perform that credit and debit operation, okay? But we made everything static before, so we no longer have a state, sorry. We cannot do dependency injection anymore, okay? So let's try to work around this problem with the first naive solution. Okay, I cannot have the bank connection into my state because I no longer have a state. I'm obliged to pass the bank connection to each method invocation, okay? So what I do here, I create my bank connection, and every time I call the open, the credit, and the debit, I have to pass this bank connection every time. And of course, I don't like it. I don't like it for two reasons. First, because I have to create the bank connection in advance before triggering all this operation. And then because I have to, it's really verbose. I don't want to pass this bank connection to each operation, okay? Because now it's just one item, but could be a tuple of items. I don't want to pass them each time. Okay, so let's try to fix these two problems once at a time. First of all, let's make it lazy. To make this lazy, it's pretty simple. Instead of passing the bank connection here, and here, I'm no longer returning with an account. I'm returning with a function from a bank connection to the account, okay? This means that I'm not doing the operation, okay? But this method returns a function that is the description of the operation that will be triggered only when I will pass the bank account to bank connection to the function. Right? Okay, so I solved the first problem. I don't need to create a bank connection here, okay? I'm just having a function from a bank connection to the account that will be the result of all this operation, okay? And when I want to apply all this operation, only at that moment I have to create a new bank connection and pass it to the function, okay? So I have to repeat this. Now I have to repeat apply connection, apply to transform the function in the result of the function, but at least everything is lazy now, okay? So let's try to recap what I've done so far. I started, this is the pure object-oriented version, right? So I have an object that has an internal state and a context that has been injected, maybe. And then I perform an operation by calling the open method, for instance, by passing some value. And then I'm returned with this object that has the context and the state. Then I call another method that I have the same instance of the object, still having the context, but with a different state. And I do this again and again, and I finally obtain the result, okay? This is the pure object-oriented version. This is the version with all static methods. Every time I call an operation, I call open, and I have to pass A, B, and the context that was the bank connection in my example, and I'm returned with S1. And then I have to call, when I call credit, I have to pass the two values, but also the context and also the S1, and I'm returned with S2. And I do this again and again, and I obtain the result, okay? The third version, the one, the lazy one, is that when I call open, I'm not returned with a state S1, but I'm returned with a function that is a function from the context to S1. I apply this function by passing the context, and I'm returning with S1. Okay? Then I call credit, and I'm returning with a function, and I do the same thing again, and I do this again and again for all the operation I want to do, and I obtain the result. Okay? This is what I am so far. Okay? So let's fix this problem with, of course, another monad. Okay? The reader monad. As I said, the monad is just a wrapper of a value. Okay, it's something that you can think to a monad as something that put a value in a context. Okay, so the optional is a monad, and the context there is that the value may or may not be there. The try is a monad, and the context is that the computation producing that value may or may not fail. The stream is a monad, and it's a monad, and the context of the value is that you could have multiple value in this case. Or the completable future is a monad, and the context there is that the value will be eventually calculated in future. Is not there. Okay. What's the specific? What is the particularity of the reader monad? The specific thing of the reader monad is that the value you put in the context of the monad is a function by itself. That's all. Okay. And then you define this map and flat map method on the reader monad that in Java, I must admit, are pretty ugly. But I don't want you to focus on the implementation. I mean, you have this reader monad in your library, probably in the JAVASLANG. You have it in the JAVASLANG library, so you don't have to focus on the implementation. You have to understand how it works. I'm just passing the implementation here. Okay, and then I need another structure. Okay, I need this structure because I cannot do monad composition in Java 8 because the Java type system, sorry, is not strong enough. Okay, so I need to define this try reader monad that is the combination of the two monad. So it has these two, the usual map and flat map method, but also has this method that is passed with a function from a reader, a function from A to a reader of B, and is returned with a try reader of B. Okay, R is the computation, is the function. Okay, so okay, still the implementation is a bit cumbersome, but it's because of Java verbosity. Don't focus on this. Okay, so let's try to re-implement this stuff again. I'm just replacing here the function with the reader, because now the function is encapsulated into the reader monad. So when I returned a try account, now I'm returning a try reader. When I returned an account, now I'm returning a reader. That's all. Okay? I'm just encapsulating the returning function inside that monad. Why I'm doing this? Because inside that monad, I can carry on the state. I can carry on that BankConnection. Okay? So what I can do is that defining this function, I'm not mentioning at all the BankConnection now, right? And I'm returning with this try reader of a BankConnection. What is it? It's just a wrapper of a function from the BankConnection to a try account. Okay? So of course, when I call apply on this reader by passing the BankConnection, I'm returning with the try account. That's all. Okay? So what I'm doing now, it's exactly the same as before, but instead of returning this function, I'm returning this monad that encapsulates the state. I'm calling a map on it, and I'm carrying on this stuff, but I'm not calling apply here by passing the context. I'm just composing the monad with itself. Okay? So this is the function. The red box is the monad wrapping it. Okay? And at the final of this combination of function, I'm returned with a reader monad that encapsulates a function that is a function from the context of the result. I pass the context to the function, and I'm returned with the result. Okay? I know this last example, it's a bit hard to grasp, or they told me so, but I believe it's a nice example of what you can do with functional programming, and my slides are on SlideShare already, so if you want, please give it a second look, and I believe it will be clearer. Okay? So what's the takeaway? The takeaway is that now we have also the functional paradigm in Java together with the object-oriented one. They are not alternative. I mean, they are complementary. You can use both, okay? And it's up to you to combine them in the best possible way, okay? And the API design is an iterative process. You try to do something, then you try your API with your test cases, and you don't like how you do what you have to do to test them, so you change them and you do this again and again, and at some point you will end up with a result with which you are happy. Try to make everything immutable by default. Try to confine side effect. Avoid the exception if you can. Try to use type as much as possible, okay? So if your computation returns 3 values, one of them is a function, another is an object that could be there or not, and another one is a value that will be computed in future. You say this with the type system, okay? You don't have to invent a fancy side effect, okay? Use an emic object and confine the business logic inside the pure function, inside static method, okay? So, okay, again, put the domain logic in pure function. I believe that functional programming is way more reusable than the object-oriented one. Throw away this stuff, learn some functional patterns, and if you are interested to learn more, okay, if you are interested in learn the Java 8 syntax and the new Java 8 API, I wrote a book about it with a couple of friends. This is a nice book about functional programming. If you want to buy just one of them, I suggest you the third one, okay? That is really focused on functional domain modeling, okay? I'm totally out of time, sorry for that, but if you have questions, I can take them offline. Thanks.